All right, looks like it's working. So today we're going to go through some math skills. So there is a lot of math in physics. I like to call physics math with a purpose. But don't tell the math teachers I say that. Actually, no, I've told them myself. Okay, so there are certain math skills that we're going to use in physics, such as scientific notation. We use scientific notation when we're dealing with extremely big numbers, like numbers that would have 20, 30, 40 digits, and you just don't want to write all those digits. Or with extremely small numbers for the same reason. Also, unit conversions. Units are very important in physics because we're always talking about something physical like distance, right, or speed. Right? If you're talking about speed, it's very important whether or not you're saying meters per second or kilometers per hour, because they mean two completely different speeds. And significant digits. We're going to talk about significant digits. Those are important. I'm sure you've punched numbers into your calculator, and you might get an answer, and you might write down every single digit. Well, we're not going to write down every single digit. We're going to round. But how many digits do you round to? 1, 2, 3? There are certain rules that guide how many digits you actually round to. And then we're going to talk about those precision and rounding rules. And finally, any errors we might have in measurements, if we are able to do some labs. I'm hoping we can, but we will see. So let's start with scientific notation. So again, we use scientific notation when we have either very, very large numbers or very small numbers. Okay, so for example, you might not want to write 124,500,000 kilometers. All these zeros are really unnecessary to write. So what we can do is we can multiply a number like this by a factor of 10. And then you just count how many decimal places you go over. So 1, 2, 3, 4, 5, 6, 7, 8. In this case, we move the decimal place to the left 8 times. So we're able to write 1.24 times 10 to the power of 8. A lot less writing. All right, so we can do the same thing with very, very small numbers. And for a small number, if we move the decimal to the right, we just have a negative exponent. Okay, I just mentioned that. So what we're going to do is I'm going to show you the first couple examples while I'm recording, and then I will stop recording. We'll do some more examples together. Good question. So a picometer is, when we're talking about units, we have a base unit like meters, and then you could have kilometers, or you could have megameters, right? Probably more used to units that high when you're looking at a computer, say, right? Bytes, megabytes, gigabytes, terabytes. Probably don't usually talk about terameters very much. Usually we don't drive that far. But then in the other direction, when you get smaller, you might like centimeters, millimeters, right? And then you're going to go down to micrometers, nanometers. You probably heard maybe nanotech a lot these days. But if you go even smaller, the next one would be a picometer. Okay, so we're going to go over units as well, because it's important to convert units. Okay. Now on your handouts, they all look the same, except this will tell you what lesson we're on. So we're on the first lesson for math skills. Okay. What's in here is basically a summary of what's in the PowerPoint. So if you're rushing to take down notes from the PowerPoint, you don't need to, for a couple reasons. One, this is the summary, and two, remember the PowerPoints are all posted on your Google Slides, not Google Slides, Google Sites, right, which is linked from your Google Classroom. All right, so I'm going to go ahead. Right, I'll go over this picture later when we're converting units. But for now, I'm going to change a couple numbers into scientific notation. So here's the first one. We have 2,395. Now, when you're dealing with scientific notation, you want one number and then the decimal. So the decimal comes after the first number. Okay, let me just zoom in a bit. Okay, so the decimal comes after the first number. And then we have 395. And then we need to multiply by a factor of 10. To determine what factor of 10, you have to determine, well, how far did you move the decimal? So initially it was here, and we moved it to the left. 1, 2, 3 spaces. So that's going to be to the power of 3. Now in this case, we don't want to write 0 point. We want a number other than 0. So we're going to write 6 point, again. Decimal's right after the first digit, 7. And we're going to multiply that by a factor of 10. In this case, we're moving to the right, so it's going to be a negative exponent. And we're moving 1, 2 spaces, so the power of negative 2. Okay, I'm going to pause the video there. Alright, so with question number 2, we're pretty much undoing what we did in question 1. Alright, so some numbers like in 1H where it said 68, we really didn't need to convert that into scientific notation. But in this case, here we have, for example, 7 times 10 to the power of 1. Now if it's just 7, you can think of it as 7 decimal 0, because we're going to take that decimal and we're going to move it. In this case, since we're undoing it, if it's a positive exponent, we're going to move it to the right. And it's to the power of 1, so we're just going to move it to the right once. So we end up with 70. Right? Down here, for example, if you have a negative exponent, so let me write 10.1, we're going to move it to the left. So to undo it, left 2 spaces, and we have 0.101. Alright, so I'm going to pause the video and let you try question number 2, and let me know if you have any questions. Alright, so we're going to talk about units right now. And the units we use are called the SI units, which are the standard international units, which are used throughout the world. There we go. So some things to know about SI units. For example, when I write kilometers per hour, that km, they're symbols. They're not abbreviation. Okay, in the States where you write miles per hour, there's no symbol for that. So they have to write a decimal because those would be abbreviations. Okay, we're not going to deal with imperial units, so you don't have to worry about that. We're just going to do metric or SI units. Okay, and we're going to practice converting units. I think we all know the basics. For example, 1 meter is 100 centimeters. In 1 hour, there are 60 minutes. And in 1 minute, there's 60 seconds. So 60 times 60 is 3,600. So in 1 hour, there's 3,600 seconds. But this is also an important one that we're going to use a lot. 1 meter per second is 3.6 kilometers per hour. Okay? And because we're going to be working back and forth between those. We tend to like using kilometers per hour in daily lives, mainly because of driving, right? Speed limits 40, 60, 100 kilometers per hour. We don't usually use meters per second, but meters per second are the base SI units. So when we're doing calculations in physics, we need to convert them to meters per second. And there are a couple of ways to do the conversion. We have this chart, which is also on your handout. So if you're given the base unit, for example, meters, and you want to go to centimeters, well, then you're going to multiply by 100. If you then want to go to millimeters, multiply by another 10. But there's a way I find that's even easier, and that's actually using scientific notation. So on your handout, we have this little chart right here under question number 2. So just this chart shows that, for example, a kilo, which we know, for example, a kilometer is 1,000 meters, but instead of writing 1,000, we write it as an exponent, 10 to the power of 3. 10 to the power of 3 is 1,000. A mega would be 10 to the power of 6, a giga is 10 to the power of 9. We tend to go by 3. Although we also have centimeters, which is 10 to the minus 2. So now we're going the other way, we're getting smaller. And then we go by 3 again. Milli would be a thousandths, micro a millionth, nano a billionth, and so on. And why are these useful? Well, let's look at the first example. Here we have 5.7 gigawatts. Don't worry about watts. That's just the unit, like a light bulb. Except I've never seen a light bulb that's 5.7 gigawatts. It sounds like something from Back to the Future. But if we were going to convert it just to watts, not gigawatts, well, I can write 5.7 and then multiply it by that exponent of 10. And giga is 10 to the power of 9. So I multiply it by 10 to the power of 9. And there you go. That's all you have to do. Again, if you want to convert it back into just common notation, then we're going to have to take this decimal and move it to the right 9 times to give us a big number, 5,700,000,000 watts. Okay, similarly, let me just go to another example. Here's 6.8 milliliters. All right, milli is 10 to the minus 3. So all I need to do is write 6.8 and multiply that by that exponent, 10 to the minus 3. And that's how many liters you have. Now again, if you wanted to write that in common notation, you do what we did back in the previous example, okay? And you would move the decimal over 3 spaces to get how many liters it is. So 1, 2, 3. You have your zeros here, and you get 0.0068 liters. Okay. Before I let you work on that, I also want to show you example number 3. So example number 3, I did say was important. We're converting kilometers into meters per second. And to convert kilometers into meters per second, you have this little chart on your previous page. If you're going kilometers per hour to meters per second, you're going to divide by 3.6. If you ever want to go the other way from meters per second to kilometers per hour, you will multiply by 3.6. So in this case, we're going to take 95 kilometers per hour and we're going to divide by 3.6, and we'll get our answer in meters per second, which is 26.4 meters per second. All right, so I'm going to pause the video there, let you work on question 2, and if you have any trouble, you can let me know. All right, so for question F, we have 548 nanometers. So first we write 548, and then for nanometers, multiply by 10 to the minus 9. But if you're writing something in scientific notation, remember scientific notation has 1 digit and then your period or your decimal. So we're going to take that digit at the end here and move it over, so we have 5.48. Since we moved it over to the left twice, we're going to add 2 to the exponent. Okay, so minus 9 plus 2 will give you minus 7. Okay, so that's why we did that. Okay, moving on, I'm going to talk about significant digits. So what is significant digits? Well, when we make a measurement on something, say, my meter sticks are gone. All my rulers are gone. All right, when we make a measurement, you say you take a ruler and you go to measure something. Most of the time you'll say, for example, it's 21.1, 21.2 centimeters. Well, that last digit you just estimated. It's a guess, right? It might be 21.13, right? But you estimated 1 or 2. Maybe it's closer to the 1, so you said 21.1. Okay, when you're making measurements, there are some errors or some uncertainties when you make those measurements. And so we need a way to account for those. So what we do is we have significant digits. And when we write significant digits, it's always assumed that the last digit is your estimated digit. That way, when you're writing certain numbers, people know how accurate your measurements actually are. If someone were to write 21.1 centimeters and someone were to write 21.13576, well, the second person probably used some really high-tech, I don't know, measuring devices with lasers or something. I don't know. Right? So one's obviously a lot more accurate. So that's what significant digits are. Now, how do we use them? How do we count significant digits? Now, there are certain rules. One rule, the first rule, is all non-zero digits are significant from 1 to 9. So for in this example, we have 259.69. Well, you can count them all. 1, 2, 3, 4, 5. There's 5 digits and they're all significant. 61.2, again, 3 digits, all significant. The next rule is that any zeros between 2 non-zero digits are also significant. Like 606. That zero is between 2 non-zeros, so it's significant. We have 3. And in this case, 4. Moving on, if we have a 0 to the right of a decimal, it's also significant. You're probably thinking, when are they not significant? We'll get to that. So 7.100 has 4 significant digits and 7.10 has 3. Now it's the exact same number, but remember, because this one has more significant digits, that last digit was the estimated one. Whereas for this person, this last digit was the estimated one. So our first person here has a more accurate or precise measurement. Say accurate. All right. Scientific notation is great to use because every digit in scientific notation is significant. Okay, again, these are the exact same numbers, but the second one is a lot more accurate. If you're counting, like if I count the number of students in a class, that's an exact number. I'm not estimating. Right? If I count 8 students, there are exactly 8 students. So that number has an infinite number of significant digits. It's not like I count students and I go, there might be 5, 6, 5.5. Yeah, let's go 5.5. I'm not going to do that. Right? So there's no estimation there, so infinite number of significant digits. Same with a number like pi. If you use all those digits, well, there's an infinite number of digits, so there's an infinite number of significant digits. All right, so let's get to when are they not significant? Well, in this case, if you have zeros to the left, like that, that one doesn't count. Right? Or if you have zeros to the right that are more of a placeholder, they also don't count. As long as they're not in between 2 non-zeros. If this was 0.2000022, then they would count, because that goes back to one of the original rules, that it's in between 2 non-zero digits. So both these examples only have 2 significant digits. And we actually have bells at this school. Okay, let me just say this one other example, and then we'll stop. Right? So if you have, say, 25,000, again, these zeros do not count. Any zeros to the right of the last non-zero digits do not count. Unless, of course, it was a decimal. If it was 25.000, that's one of the rules where it counts. Right? So I'm going to stop there.